I can solve multi-step inequalities and graph the solution. The vocabulary that you need to be familiar with is less than and an open circle because there's no line underneath that symbol, less than or equal to, which would mean a closed circle, greater than with an open circle, or greater than or equal to with a closed circle. Something that I was shown a few years back that made a real difference in how I looked at these things was if you draw a number line and you know that these numbers are positive and getting bigger, and you know that these numbers are negative and getting smaller, that means this symbol here means greater than, and this symbol here means less than. So if you ever have trouble remembering that, just draw a quick simple number line and the arrows at the end of the number line will remind you. Okay, let's go ahead and check the next one. This says the steps for solving an inequality are the same as the steps for solving an equation, but you cannot check it in Desmos for a solution. And also, when you multiply or divide by a negative number, you have to flip the inequality symbol. Now, when you look at this first line, see how you have distribution? Negative 3 times x is negative 3x. Negative 3 times negative 4 is positive 12, greater than 15. This is the step right here where I check to see whether or not I'm going to be switching an inequality symbol. If the number, the coefficient, in front of the variable is negative, then you know that at the end your symbol, your inequality symbol, will have to flip. Okay? So after you distribute, after you combine like terms if needed, after you move a variable from the right side to the left side, that's when I check to see, is the coefficient in front of the variable a negative? If so, you know in the end your inequality will have to flip. So let's go on with solving. We're going to eliminate the constant by adding our negative 12 on each side. We're going to bring each piece down. Then we're going to eliminate, or we're going to isolate the variable by getting rid of this coefficient, which means we need to divide by a negative 3 on both sides, which flips the inequality symbol, and we get x is negative 1. Since that does not have a line below it, okay, but it did flip, we are going to have an open circle right here at negative 1. That's where it tells you where you're going to put your open circle or your closed circle if you need it. See how the arrow is pointing toward this side? If you pretend that's an arrow, and you make it an arrow if you need to, it's pointing toward the negative numbers or the smaller numbers. So that's how you know which way the line goes. Now, this here, x less than negative 1, is called a solution set, but possible solutions are what makes it work on a number line. So if you'll look here, a negative 2 will definitely make it work because it's on that number line. Negative 1 will not because it's an open circle. How about negative 3? Negative 3 is also on that number line. And because of the arrow, it goes on forever, so we'll also choose negative 5 as a possible solution. Now this says which represents the solution set, just the solution set to the inequality below. So we're going to solve this. We've got 16 greater than. We can go ahead and bring that down if we like. But then we have two different x terms and a constant. So we're going to use a t-chart to put those terms together to combine like terms. We've got a negative 3x plus a 5x minus 8. So if I come over here and use my calculator, negative 3 plus 5 is 2x. And you bring down the negative 8 because there's nothing else to put it with. That comes up to this line, 2x minus 8. Then we're going to continue. We have to get rid of that constant, so we're going to add 8 on each side. All right? So again, I know a lot of you can do this, but please use your calculator to make sure you don't make mistakes. 16 plus 8 is 24, greater than 2x. And now we know we have to isolate the variable by dividing. And then I'm going to go ahead and use my calculator again just to show you. 24 divided by 2 is 12, greater than x. But there's a problem. The x is on the right, and in our solution sets, the x is on the left. When you switch the x and that number, you also have to switch the inequality. Otherwise, it will not be correct. Okay? So x is less than 12 is really the same as 12 is greater than x. But you have to have the x on the left to write that solution set clearly. So when you switch the x over and the 12 over, that's another reason that you would have to switch the inequality symbol. All right, let's look at the next one. Determine which inequality the number line below shows the solution to. Wow, this one could be a lot of work if you're going to sit and solve all 4 of those. But let's talk about it a little bit and see if we can't eliminate some choices. First of all, notice this is a closed circle. To have a closed circle, you must have an equal to in your inequality. A has one, but B does not, so B can be eliminated. C also does not have an also equal to, but D also has an equal to. So A and D are possible solutions, okay? The next thing I'm going to look at, and I will solve the one we choose just to be certain and show you, but do you see here how this has a negative in front of the variable? That means in the final answer, this inequality is going to have to change directions. So does that match what our solution looks like? It definitely does. It's pointing toward the right. But let's go down to the bottom. Again, look at the negative in front of that coefficient that's with the variable. That means eventually this symbol is going to have to flip. Oops, I wrote the same one. That won't work. Let me flip it. That means it would have to go toward my left. So think about it. Which one do you think will match this arrow going to the right? My thought is it's A, but let's go ahead and prove that to everybody, because in a lot of instances, you can just look really carefully and figure these out. So first thing we're going to do is get rid of that constant. So we're going to subtract 5 on both sides. That gives me a negative 3x less than or equal to, and again, I'll show you to use the calculator. I don't think there's anything wrong with that to make sure there's no silly mistakes. And then we're going to have to divide or isolate that variable by dividing by 3. Of course, you divide by a negative, your inequality symbol is going to flip, brings down an x, and you get a negative 6. Well, if you'll notice, the closed circle is at negative 6, and the arrow does come to the right. So we are correct. A is our answer. Now this says select all solutions. So we're going to have to solve it, then draw a number line real quickly to make sure we pick the correct solutions. So let's start. Now first of all, we have variables on both sides. So we have to box the one on the right, do the opposite to make sure it moves to the other side. 4x plus 2x is 6x. My negative 8 comes down, less than a positive 1. I make it a habit to bring the sign with that, just so that I don't forget a negative, because that would make a big difference. I'm going to eliminate the constant by adding 8 on each side. Bring down my 6x less than 9. And then I'm going to divide by 6 on each side, which gives me x is less than, and let's go ahead and put that in the calculator. 9 divided by 6 is 1.5. So I'm going to draw a number line because I always draw a number line to make sure I'm doing the right thing. So I'm going to put a 0 here and a 1.5 there. That says less than, so it's an open circle at 1.5, and it points to my left. So that means anything smaller than 1.5 is a solution. Is negative 3 smaller than 1.5? It is. Is negative 1 smaller than 1.5? It is. Is 0 smaller than 1.5? It is. Now I'm going to look at 1. If this is 1.5, then right here is a 1. Is 1 smaller than 1.5? It is. And then a 3 would be out here somewhere, so that is not that is not a solution to this inequality. All right, that looks where that stops.